Okay, today we will be learning how to sketch the graphs of the rational function. By the way, this is your, what to give you your booklet. So, if you need to sketch, for example, if you need to sketch a graph, for example, of the function f of x equals 1 over, let's say, x squared minus x minus 6. So this is a reciprocal relation. So to sketch this reciprocal graph, we need first sketch the graph of the function in the denominator. So, sketching the graph y equal x squared minus x minus 6, factorize it, x minus 3 times x plus 2. So we have minus x-intercept minus 2. X minus 2 and 3. And what will be the turning point? How we can find coordinates of the turning point? We either can turn into that turning point form, or it always average between the x-intercept, so minus 2 plus 3 divided by 2 will be 1/2. So we have x of the turning point is 1/2. We can sub it into the equation. We will get 1/4 minus 1/2 minus 6 will be equal negative 25 on 4. So we have 1/2 negative 25 on 4. And this is the graph of the denominator. Now, when denominator equals 0, will be a reciprocal function exist?
No, asymptote.
So there will be asymptotes. So where denominator equals 0, we have asymptotes. X equals 3.
Will there always be asymptotes, or can they be just by some?
If there will be where denominator equals 0, it will be asymptote.
Undefined, but like it's always an asymptote, right?
Yeah.
Yes. X equals 3. Asymptotes. Now, here, when x approaching infinity, we have denominator approaching what?
0.
Denominator approaching infinity as well as growing, denominator growing. So the reciprocal approaching 0. 1 over very big number will be very small number. So we have another asymptote.
Y equals 0.
We have asymptote y equals 0.
Variable y. I just said it.
Y equals 0.
Yeah.
Because when x approaching infinity, what happens with the denominator? X squared minus x minus 6 will be approaching infinity as well. You see, it's going to infinity. 1 over that will be approaching 0, which will be asymptote. So that will be this graph of the reciprocal. Make sense?
You can't do the other side.
Here, where we go when it's coming to 3, denominator coming to 0, approaching 0, 1 over some approaching 0, approaching infinity. And it's positive, so it will be positive. Same thing we will have here. It will be exactly the same thing.
Oh, like truncus. Just like a dilated.
But what will be in between?
Nothing.
No, there is
What do you mean? Where we have smallest value of this,
closest to 1.
when the denominator is the smallest, 1 over that
The maximum.
will be maximum.
Like within the other.
Will be maximum, and we have value minus 25 on 4, so we have 1, value of y will be 1 divided by negative 25 on 4 equal negative 4 on 25 for the same value of x. So we have here will be maximum with the coordinates 1/2, -4 on 25. That will be maximum. But that will be maximum, and then it always will be negative. And again, when we approach into -2 and 3, it will be approaching negative infinity because the denominator is negative. So that's how we sketch in those reciprocal graphs. We need to look on the denominator, and you sketch denominator. Then when we have x-intercept of the denominator, there will be vertical asymptote. And when we have the minimum of the denominator, the reciprocal function will have maximum. Because when we divide by the smallest number, we'll get biggest number. Makes sense how we sketch this graph.
Yeah.
And even without doing any differentiation, we identify where the turning point is. Make sense?
How do you do a sketch?
Hmm?
That is a special.
How we derive? We can find derivative of
Two x
this.
minus
So
one
what I
x
mean is
equals
like
zero.
if there's a stationary point, will the x coordinate will stay the same, but the y coordinate will be what?
1 over, yes.
1 over as well.
Yeah, because we have,
Oh yeah.
this is everything we divide.
Will it be the same concavity? Like if it's like a positive stationary point, will it also be positive?
To what degree?
Sorry?
I mean, like, well, if there's a stationary point with the original graph on the denominator,
Yeah,
will 1 over also have the stationary point?
yes.
Will it be like the same?
But in the opposite, what was minimum becomes maximum, maximum becomes minimum. Now, does that make sense? Any other questions?
Yeah, what's not so far?
No. Another example. Now let's consider what if the quadratics in the denominator is non-factor. Where quadratics in the denominator is non-factor.
I mean, no asymptotes.
So we have, if we have f of x equals 1 over, let's say, x squared plus 1. Let's say y equal, f of x equal 1 over x squared plus 1. We will be no vertical asymptotes.
But
But-
at -1 it's 0. It's
So first we sketch again, we sketch graph of the denominator. Y and x, we have the graph like this. This is the graph of x squared plus 1 of the original function. When we divide, do reciprocal. When we have x approaching infinity, very big denominator, so fraction very small. We have asymptotes. We have horizontal asymptote y equals 0.
Will you always have a horizontal asymptote? Like whatever graphs you get like this.
No, not always, but most of the time. Now,
Oh, if it's root x.
if we have,
Oh, no.
now, what will be the maximum? We have minimum, original function has
Maximum
minimum.
is minus
So
one.
reciprocal will be
What?
maximum.
Yeah.
And the graph will look like this.
Blah blah blah. Oh, that's a derivative sketch or something.
That's not derivative, it's reciprocal. It's reciprocal. That's how, so when we have denominator non-factorable, we'll have graph something like this. Yes?
Your line's not approaching the
Hairy line,
so
hairy
get a
line.
mark off.
Where? It's not
On
approaching.
the right, it's not approaching. So you get
It
a
is
mark.
approaching.
Has to be, I have to go.
Yeah.
Where are you going, Jack?
Good luck, soldier.
Yeah, which sport?
Footy.
Oh, you're not going for the other.
What am I going to do there? Play footy.
Okay.
How do they play for?
So you're staying
Oh,
here.
why can't you?
Gentlemen, let's get back to graph. So does that make sense how we made this graph?
Yeah. Will there be ever a case where x approaches
No.
infinity?
Now let's consider when we have the power,
3.
because we have just 1 in the numerator. Now if we have, for example,
Oh, there we go.
two polynomials. We have a f of x is a quotient of two polynomials. F of x is a quotient of two polynomials. Example, 2x cubed plus 3, 2x cubed plus 3 divided by x squared plus 1.
Do you do that?
So first step we need to do what?
That thing, they separate the fractions.
We can divide numerator by denominator. In this case, it will be it will be pretty simple to divide. Sorry, x squared. No. The 2x squared plus. We'll get to other way as well. I wanted 2x squared plus 3 over x squared plus 1. How if we divide?
If I divide I get 2.
Easiest way how we can simplify. We can make this as 2 times x squared plus 1 numerator.
Yeah.
Divided by x squared plus 1. We have 3 is 2 plus 1.
Plus 1 and x
It's
squared
2
plus 1.
If you expand this, you get 2x squared plus 2 and plus 1.
Yeah.
So
it's 2
So that
one
equals
is
2
Plus 2.
plus 1 over x squared plus 1. So we just sketch the graph 1 over x squared plus 1.
But now
What this will do with this
Translate
graph?
to minus
absolutely
5.
ask themselves.
It will be the translation to up. So the only thing we
Yeah,
change,
is 2.
then we will have asymptote equals y equals 2. Y, x, and what will be the turning point?
The turning point would.
No.
It's a
It was
Zero, two.
no, we
One.
had just we did
One,
we just
zero, 0, 2.
will be 0 2.
Lana.
So
No, it'll be 0-3.
no 0 3.
0, 3.
Why 0 3?
Because it's 1, and then it flips, so it's
So we have y equals 2, then this is 3, and that will be the
The
graph.
turning point is at 0.
We had before, when it was 1 on x squared plus 1, we had turning point 1 0. Now we translated everything to up. So we get
Look at the bottom
right.
graph. What's the turning point at the bottom?
Yeah.
Mr. V,
right.
Miss Sawyer said that specialist is easier than Methodist. What do you think about that?
who said
this way.
that specialist is easy?
Yeah, that's it.
No, I disagree. The mathematics is harder in specialist, but
The thinking.
the wording of the questions in methods is worse than wording of the questions in specialist. I'm talking about the exam first of all, because people who write the methods exam,
Idiots.
they're not idiots, but they like not very well formulate questions. In special, usually they're better formulated, so you don't need to. It's not that hard to translate from English into the mathematics. In methods, sometimes questions are mathematically not hard,
Yeah.
but translate from English to mathematics is very hard because it's hard to understand what the question talking about, what they want from you. In this term, specialists is easier because specialists written in the better language, exams, at least usually, than methods. Okay, that's another example. One more example. Now we will have that power of the numerator is greater than denominator.
I'm so hungry, Mr. V.
Huh?
I'm so hungry.
Save.
He's hungry for maths.
Hungry for chicken.
Oh, lava.
I cannot help you with that.
Wait, should
Same here.
just run away from school? What did I always said something here.
Probably just something racist.
So what we need to do now?
Divide.
First step, we should
Long
divide.
division.
We should divide the top polynomial by the bottom. So we do 2x cubed
You can do that.
plus x squared minus 1 over x squared minus x minus 2.
They have to be plus 0.
Now here,
0x.
very good observation, we're missing term with x, so we need to write plus 0x.
I did
You
that.
don't.
0x
Yes, you do.
minus 1.
Yes, you do.
Even if you don't want to make silly mistakes,
0x.
then you do. If
If you're a
you
genius
want
like me, you don't need to do it wrong.
okay,
If you're
so
a genius-
2x cubed over x
Jason,
squared,
do you think you're a
we have
genius?
2x,
Come on, you.
we have 2x, multiplying this by 2x minus 2x cubed, we have minus 2x squared.
Plus 2x squared.
No, I minus, when you
Oh,
multiply
yeah.
the minus, and we have minus 4x, and then we subtract, we get, then it will be
Yeah.
plus, so we get 3x squared, 3x squared, plus 4x, minus 1, then 3x squared divided by x squared is plus 3, minus 3x squared, minus x times 3 minus 3x, minus 2 minus 6, and we got the remainder 7x, 7x plus 5. What does it mean? That we can rewrite this function as 2x plus
He got it
3.
wrong, Mr. B.
What?
He's a genius, though. He's a genius.
For 1 second.
2x plus 3 plus 7x plus 5
Oh,
divided by x squared minus x minus
Wait, my
2.
log division isn't working.
No.
Now,
No, I'm pretty sure.
So-
Copy the question wrong.
what is where to go now?
My log division isn't working.
no clue.
Now, first of all,
Copy the question wrong.
in this case,
Mr. B, where'd you get the minus? Sorry, where'd you get the minus 4x from?
Oh my god.
multiplying minus 2 by 2x.
Get it out the sky.
Minus 2 multiplied by 2x will be minus 4x.
What?
Now,
I didn't get it wrong.
here is very important thing. When we have, let's think, what happens to the whole function when x approaching infinity? When x will be very big, what this fraction will be approaching?
0.
0.
Yeah.
Because denominator is higher power.
But that is approaching infinity.
Yes, but the graph will be approaching this. Because this will be pretty much 0.
So small.
So now we have, in such case, we will have a oblique asymptote.
Sorry, what?
The y equal to x plus 3 will become an asymptote.
Negative 3 and 2.
Not negative 3 and 2, 2x plus 3. Why the line to x plus 3? Because
Oh.
when x will be approaching infinity, our graph has to be approaching this line. Because this will be very, very small.
That's it.
So now, factorizing this, we have x minus 2 times x plus 1. So we get two vertical asymptotes. X equals negative 1. X equals negative 1. We have another vertical asymptote, x equals 2. X equals 2. We have oblique asymptote, y equal 2x plus 3.
What does oblique mean?
Means that going
Oh,
at the not vertical, not horizontal, at some angle.
right.
So we have another asymptote. Now the x-intercept will be minus 3 and 2. So it will be here. This is 3. So that we have another. So we can have asymptotes like this. We can have asymptotes. I will write this more to the right so have same have room for the graph. 2x plus 3 plus 7x plus 5 over x squared minus x minus 2. And I will clear it here. So we have the. Now, let's start. We have three. Now, when the graph, when we have x approaching infinity, the graph we found that y equal 2x plus 3, approaching this. Will it be approaching it from the top or from the bottom?
From the bottom. Oh no, from the top.
From the top, because we still will be adding something very, very small,
Yeah.
but still adding. So we have, the graph must go here like this. Now, when x approaching 2, because this approaching 0 and that approaching infinity, we can have only one option that the graph went like this.
Why?
Because when it's approaching infinity, we have oblique asymptote 2x plus 3, and graph have to be approaching it. But when we approaching x approaching 2 from the right, this approaching 0, because this equals 0 and x equals 2. When the denominator approaching 0, what fraction approaching? Infinity divided by 0 is going to infinity.
Yeah, 2x plus 3.
Yeah, but how do you know the line comes down as x goes from 2?
What? Sorry, can you repeat?
It's a
Like
constant
after
line.
x equals to 2.
Well, after x equal to, we already established that
Yeah.
we have asymptote to x plus
Yeah.
3. And it coming to it, but from the top. Because this is not 0. It's very small.
Yeah.
It's approaching 0. But we're still adding something to 2x plus 3. So this line has to be above 2x plus 3. This line has to be above. Then here it should go to infinity as well, because when x approaching 2, this approaching infinity. So the only possible way it have shape like this.
Well, why is it approaching infinity when x is approaching 2?
Because what this, when x equals 2, what this equal?
Oh.
What denominator equal?
My bad.
0.
0. Yeah. Now, the same reasoning we can apply here when we have negative, and we will have something like this.
Oh, why under?
It's negative. X is negative.
When we will have this,
I don't get it.
So basically, like
so here, when we approaching negative infinity, yeah, this approaching
small.
positive infinity, so this will be 0. But x is negative, so this thing will be very small but negative. So we will be minusing from 2, so it has to be below 2x plus 3.
Right.
Make sense? My reason or not?
Ish.
Yeah, so
No,
basically,
really?
the
That's
closer it gets to the x-axis to the middle, the left-hand side becomes irrelevant and the right-hand side becomes really big approaching infinity. And the more out you go towards infinity, the 2x plus 3 becomes like dominant. And the right-hand side, the 7x plus 5 and x squared minus x minus 2 approaches 0. So it's basically just like 2x plus 3 just to infinity.
Now, what happens in between?
Oh, there's a
What happens in between negative 1 and 2? What happens in between? So,
That's the
I'll-
trouble. Wait, how does when x approaches negative 1, how does that thing?
x approaching what?
Negative 1, how does it, why does it?
Again, same as here. Same as here, this will be approaching 0.
It becomes a fraction.
Yeah, and then the top will be negative, right?
Yes? So we will have, this is negative number.
My bad.
When we-
my bad, my bad,
Yeah.
my bad.
Yes?
Would it be a good idea to sub like points like 1 in just to find like in between?
Yeah, because they're all ugly points. Because between 1 and 2, and you don't have like 3 onto equation like that.
Huh?
Sorry, can you
Yes,
repeat?
I
Would
agree.
it, be, would it be a good idea to
So-
sub points in that are in between the two asymptotes to find the shape?
Yes, it will be negative 1.
No,
Why negative 1?
substituting few points will not give you any idea about the shape.
Would it be in like a cubic shape?
Now, here, in between them, this will be insignificant. This will be important. Let's see. When we come in, no, first, when x equals 0,
Y-intercept?
what will be the
Uh-huh.
y-intercept?
Yeah.
Y-intercept will be positive 1/2.
And
Oh,
x
yeah,
equals
that's-
1, x equals 0. X equals
No.
1, y equals negative 1.
No.
Is it a cubic?
Hmm?
Is it like a tangent?
Then we have, when
It's not a cubic.
when we have
Something else.
this coming to negative 1 from the left, coming here to negative 1 from the left, sorry, from the right, we're coming from the right.
Oh, it's gonna be really big.
This becomes very, very small, positive or negative now.
Negative.
Positive.
This
Negative.
positive, this
Yeah,
positive,
positive for the whole
but
thing.
this whole
Negative.
thing negative. So we will be approaching negative infinity.
I have a question, Mr.
So it has to go.
This will be all like this sum x in.
Now,
This is
when
actually-
we come in, so 1 second.
This is between negative 1 and
Yes,
0.
yeah,
This is a
just
fraction.
use it, yeah.
This is a fraction.
Yes.
So something fraction is smaller than this minus that, so this can actually be
There's
negative.
no point of.
Yeah, that's not what I'm doing.
You know what I mean?
No, the whole fraction will be negative.
No, but this will be negative and this will can be
No,
positive. Because this is between negative 1 and 0. So
Sorry,
the
sorry,
output is
sorry.
small.
Yeah, this
Yeah.
will be,
Negative.
this will be,
Negative.
no, this is negative,
Yeah.
and this is negative,
Should be positive.
but negative is positive, so we will have, it will go to, we can check it if it's substitute, let's say negative, it has to be positive, because substitute negative
It's
on
a
how
positive.
yes. So graph will go here, approaching, this will be asymptote. When we approach because this is negative, well,
Yeah.
that's negative, this is negative here. So this whole thing is positive, and it will be very big positive now, because this is close to 0. This is close to 0.
If I just sub in x equals 1, negative 1, what, point 1, negative 1.
If you
how do
substitute
put
x equal negative 1,
X
you will
equals
get
one.
0 in the denominator.
I said x equals 1.
I said 1.
1, and what it will give us.
Did you get it, Toby?
Okay, that.
But what it will give us.
I don't know where it's approaching.
No, the idea is approaching, when we approaching to negative 1. When we approaching from the right to negative 1. What happens with this? This approaching will be approaching positive infinity. No, this will be approaching negative
Why?
infinity. No, 1 over.
Well, why?
This approaching, denominator approaching 0
Yeah.
and will be negative.
Why?
Graph, how the graph, if you sketch this graph, x squared minus x minus 2, it has, it is this graph. What is it here? Very small, negative. This is a graph of x squared minus x minus 2. Here we are here. It is very small negative number. So this is very small, this is negative as well, because we in negative numbers. Negative by negative, divided by negative is positive. But because this is very small, that will be very big positive number, so we have asymptote this way. When we are approaching 2, that will be other way around. There will be asymptote approaching here. We will get, this will be still negative, but this will be positive.
I don't get why it's negative to the bottom.
Here,
Joseph, shut up.
look on this, on the graph of the denominator. This is denominator. Here this is x squared minus x minus 2. At this point, it's positive or negative. At this point, is it positive or
Oh,
negative?
approaching, it's negative.
It's
Right.
net approaching.
Yeah.
So it will be negative, very small negative. and this will be positive here. Positive divided by very small negative will be very big negative number. So that will be the shape of the graph. And what will be,
Wait, how is it crossing the
Because the
asymptote?
asymptotes are only for the above.
it is asymptote only when x approaching positive or negative infinity.
Okay.
Remember, graph can cross
Yeah.
asymptotes
Yeah.
somewhere. Here in asymptote, yes,
If you sub in a small negative number, then I don't understand how it's...
not small negative number.
Oh, no, we...
Not small negative. We substitute, when we're talking about asymptote, we substitute the numbers close to negative 1.
So then how does that...
Close to negative 1.
Oh, okay.
To make these be close to 0.
Yeah, okay.
So the only possible shape will be something like this.
So you get y.
At this stage, yes,
For the
Square.
asymptote, would it be, in like a test or something, would it be correct to remove the middle part of the asymptote and have it on either side, or is it fine to have it all the way?
and on the exam, you sketch the whole asymptote.
Okay.
You can, but it's graph. You can have asymptote crossed, but somewhere else it's approaching.
Do we need to label the
No. At this point, at this stage, you are not required to find any stationary points on this.
Yeah, I think...
At this stage. Next year, yes. Next year, yes. More for the SAC on SPECH, you will not have. No, I will not tell anything yet. I will tell you later. I'll double check
Okay.
because I think I had one question.
Oh.
I'll double check. But does it make sense? As I'm saying, at this stage, you're not required because to find the stationary points, just the shape of the graph here. And I'm not asking about the stationary points here without calculator. With calculator, you can find
This is
it.
like addition of order, it's just a lot harder.
Yeah.
Yes.
Agreed.
Okay, that's pretty much all about the graphing for today. Like, subscribe and donate to help fight Russia, Hamas, Iran and whatever.
A lot of them.
And support Ukraine and Israel.
Yeah.